Hi all, I am myself Stency Vias. I am Assistant Professor in Computer Applications, Mercy College, Palakkad. My dear students, today we are starting our computer organization and design through online. So, our first topic is the digital logic. Okay, now we can start about our questions, that is digital logic. Okay, does anyone of you know what the term digital logic means? Any ideas? Yeah, most of you will be aware of the digital term digital logic. Uh, it's a general definition of a computer that is you are studying from the little age itself, that is computer is an electronic device which calculates or which is used to do arithmetic operations and all like that. You are all aware of the definitions like that. So computer is an electronic device and it works using electricity, that we are all aware of that. Okay, so basically this computer works while we are passing some electricity to it. So while thinking of this electricity or the current, we have only two possibilities. That is, one is the voltage with high voltage and with no voltage, zero voltage or low voltage. We can mention it like that. So we have two states of electrical passage, that is one with electrical passage and one with no electrical passage, as similar to the switches that we are using for lights, fan and all like that in our home and era. So we are using we all know that computers understand only binary or machine languages, and it is composed of zeros and ones. These zeros and ones in the language or computer language represents high and low voltage correspondingly. So here one will be we come across two type of logic systems, that is positive logic and negative logic. In positive logic system, we are having or we are using 1 for high voltage and 0 for low voltage. Whereas in negative logic, it is opposite of the positive logic systems, that is, we are using 0 for high voltage and 1 for low voltage signals. So this is the basics of digital logic. So do you know how the digital waveforms or representations or graphical representation of this waveforms will be? It is basically in a square shape. So we are having two edges, that is one rising edge, that is from low voltage to high voltage. If the voltage fluctuation is low from low to high, then we will be having a rising edge, and if it is from high to low, we will be having a falling edge or trailing edge. So the clock pulse, the positive clock pulse will be look like this, and the negative clock pulse will be look like this. Okay. Next, if you are talking about the logic or logic circuit or like that, or even flip-flops or some mini circuit, basic circuit is this flip-flops. Flip-flops are the basic fundamental components that is used for storage and all other purpose in a computer. Major computer circuits or logic circuits are done or created basically using this flip-flops. So a gate can be considered as a circuit with any number of inputs but only one output. This is a basic definition of this logic gate. And there are various types of logic gates, and the logic gates process signals which represents true or false or zeros or ones or high voltage or low voltage. You can take it as anyway. Okay. And there are three types of logic gates. Those are basic logic gates, universal logic gates, and special logic gates. Basic logic gates, we are familiar with this, and or and not gates. Universal gates are, we have two universal gates, NAND and NOR, and two special gates, XOR and XNOR. Okay, just we can go through this basic gates. First, we are discussing the basic gate, and this is a logic circuit representing AND gate, and this is a basic truth table for AND gate. And as we all know, if any one of the input is 0, the output will be 0, and in only one condition in which both the inputs are high, the output will be high in an AND gate. Next is the NOT gate. NOT gate is also called inverter, and any input given to this NOT gate, it will be the output will be just opposite of this input. And this is a logic circuit, and here is the truth table. An input 0 is given, then the output will be 1. If the output is 1, the input is 1, output will be 0. Next is the OR gate. As the name suggests, any of the input is high, the output we get a high output. This is the logic simple for the OR gate. It has two inputs and one output, and here is the truth table. Only one condition, the output will be 0, that is if both the inputs are 0. In all other three conditions, the output will be 1, that is if any one of the input is high, the output will be high. Next, we are discussing the NAND and NOR gates, that are our universal gates. And we have come across why these NAND and NOR gates are called universal gates, and also NAND gate is also similar to similar or considered as a combination of NOT and AND gates, that is NOT gate, inverter gates, and AND gates. And the logic simple for this NAND gate is like this, that is an AND gate with a bubble for representing the negation operation. And here is the truth table for NAND gate, that is this gate is a negation of AND gate. And while recollecting the AND gate operations, these three outputs will be 0, and here it will be 1, and NOT and inverting that outputs. These three operations are high, and while the two inputs are high, in NAND gate we will get a low output. And next is the NOR gate. Similar to the NAND gate, NOR gate is also represented as NOR with a OR with a bubble for representing NOT. And NOT is also is a combination of NOT gate and OR gate, and it is also the negation of OR gate, in which if the two inputs are 0 or low, the output will be high, and in all other cases the output will be 0. XOR is an exclusive OR gate. This is the logic simple for the XOR gate, and here this is used considered as a XOR symbol. Okay, and exclusive or exclusive, that is if the two inputs are similar, that is if both are 0 or 1, then the output will be 0. In other two cases, that is if one input is 0 and one is 1, the output will be high. And next is the XNOR gate. XNOR gate is just opposite to XOR gate. That is, if both the inputs are similar, the output will be high, and in other two cases, output will be 0. Now, I'm just giving a basic idea of two-level logic gates. Here I have given two logic circuits. First logic circuit, we are using two AND gates with 4 inputs, that is 2 input fed into one AND gate and other 2 inputs fed into another AND gate, and the outputs of these 2 AND gates are given to the third AND gate. Here these 2 AND gates are considered as the first level of this logic circuit, and this is the second level. And here in the second figure, we are using 2 AND gates and 1 OR gate. These 2 AND gates are considered as the first level, and the second level we are using 1 OR gate. So these two are two-level logic circuits. And we have two categories, degenerative form and non-degenerative form, that we will discuss on the next session. So now I am going to give you some exercises on the basic idea and writing the truth tables. In this, you will be seeing some logic circuit in the screen. You all take it down. We have 3 inputs and final output, one final output. We are using 3 gates. One is an OR gate, other is an AND gate, and the third one is an OR gate. Okay. So we have to create the truth table for this circuit, and I will just give an idea of how to write the or create the draw the truth table. And here is the idea to write the truth table. We have to represent the 3 inputs and only the final output in the truth table. So just write all the possible combinations of these 3 inputs, that is 0 0 0, 1 0 0, 1 0 1 0, 0 0 1, 1 1 0, 1 0 1 1, 1 1 1. And we have 8 possible combinations, that is 2 raised to 3, which is equal to 8 possible combinations we have written in it. And while giving these inputs to these gates, what will be the final output? You have to fill it in this column. Okay. I think you will have taken out this circuit. So do it. And here is another exercise. Take out this circuit also. We will be discussing the output or the truth table values on the next class, and continue with our creation of continue with our basics of in digital logic and basic electronics. Okay. Have you taken out this circuit diagram? Okay, I will post the 2 homeworks in your LMS, that is Moodle. You just work out this and create the truth table for this logic circuits, and we will be discussing in next class. Okay, girls. Thank you.